ये चेक करें, वो कह रहा है the first part is saying that 3x plus ky equals to 8 and x minus 2 times ky equals to 5 are simultaneous equations where k is constant. ठीक है, आगे वो कह रहा है show that x equals 3. अच्छा, अब इसमें आपने k से परेशान नहीं होना कि ये थर्ड वेरिएबल आ गया, ये थर्ड अननोन आ गया. ठीक है.
जी
अच्छा, मतलब whatever the value of k is, the good thing is it is a constant and both equations we have k. अगर किसी एक इक्वेशन में होता तो फिर प्रॉब्लम हो जाता. अभी यहाँ पे एज सच कोई प्रॉब्लम नहीं है, तो इसको आप सिंपल जिस तरीके से नॉर्मल आप साइमल्टेनियस इक्वेशन सॉल्व करते हैं बिल्कुल उसी तरीके से करेंगे. और हमने क्योंकि x की वैल्यू को शो करना है कि वो 3 के बराबर है, जो पार्ट ए है, सो वी विल बी एलिमिनेटिंग y. So in order to eliminate y, we have minus 2 coefficient here, we need plus 2 over here. So I'll be multiplying equation 1 with the 2. तो वो आ जाएगा आपके पास 6x plus 2ky equals to 16. ये आपके पास equation 3 आ गया. ठीक है. Now I will be adding equation 3 and 2 together. So add equation 3 and 2. So 6x plus 2ky equals to 16 and then x minus 2ky equals to 5. यहाँ से हम जब इन दोनों को ऐड करेंगे तो ये आपके पास ये दोनों कट गए, तो आपके पास आ जाएगा 7x equals to 16 and 5 is 21 and then x is equals to 3. ठीक हो गया. क्वेश्चन नंबर इसका पार्ट ए हो गया, 3 मार्क्स का था. आगे वो कह रहा है गिवन दैट द वैल्यू ऑफ y is 1/2. ठीक है. एंड द वैल्यू ऑफ y is 1/2. उसने खुद ही दे दी है y की वैल्यू. अब आपने k की वैल्यू फाइंड करनी है. सो नाउ यू हैव द वैल्यू ऑफ x एंड यू हैव द वैल्यू ऑफ y. All you have to do is simply choose either of these two equations and find out the value of k. So let's just pick the first one. So the first equation is 3x plus ky equals to 8. Now I'm going to substitute, like put x equals to 3 and y equals to 1/2 in this equation. So you can even write it down. So put x equals 3 and y equals 1/2 in equation number 1. So 3 times 3 plus k times 1/2 equals to 8. So k over 2 equals to 8 minus 9, and k over 2 is minus 1, and then k is -2. ठीक हो गया.
जी सर.
ठीक हो गया. अच्छा, नेक्स्ट है क्वेश्चन नंबर 5. 2x minus py equals 5, 4x plus 5y. ये एग्जाम क्वेश्चन होंगे. ठीक है, अभी एग्जाम क्वेश्चन अभी मैं आपको दिखा रहा हूँ. 4x plus 5y equals plus q equals to 0 are simultaneous equations where p and q are the constants. The solution to this pair of simultaneous equations is x equals q and y equals -1. तो ये तो प्रॉब्लम आधा ही यहाँ पे सॉल्व हो गया. ठीक है. फाइंड द वैल्यू ऑफ p and the value of q. 5 मार्क्स का क्वेश्चन है ये. अच्छा, so 2x minus py equals 5 and then 4x plus 5y equals minus q. Now, p and q, the examiner is saying that they both are constant. And in the next line, examiner is saying that the value of x is q and that of y is -1. So I'm going to put this in both of the equations. So the first equation is going to be 2q minus p. Okay, y is -1, so that's going to become plus p equals to 5. Okay. And the second equation would be 4q. Okay, if I bring this q back here and combine it with this one, plus q minus 5 equals to 0, because I'm putting -1 in y, so that is why it has changed to -5. So this is going to be 5q minus 5 equals to 0. So you can easily get the value of q as 1 from here. 5q is going to be equals to 5, and then q would be 5 over 5. So that is the value of q. Okay. And then for the
Yes.
value P, you can use this value of Q in the first equation and you can easily find the value of P. Okay, then P is going to be, I'm doing it directly. P is going to be 3. If you put Q as 1, the 2 goes on the other side, 5 minus 2 is going to be 3. ठीक हो गया?
जी सर.
अच्छा, नेक्स्ट है आपके पास पेज 40 पे आ जाए. पेज 39 पे पहले मैं देखूं. पेज 39 पे तो नहीं है कोई एग्जाम क्वेश्चन?
नहीं सर.
ठीक है, पेज 40 पे आपके पास एग्जाम क्वेश्चन शुरू में दिए हुए ऊपर क्वेश्चन 4 और क्वेश्चन 5. एक लीनियर है और एक क्वाड्रेटिक है. 6 मार्क्स का क्वेश्चन है. सो एक इक्वेशन है आपके पास x plus y equals 3 and x square minus 3y equals 1. इसको आप सब्स्टिट्यूशन मेथड से भी कर सकते हैं, इसको आप कंपैरिजन मेथड से भी कर सकते हैं. तो व्हाट मेथड डू यू वांट मी टू डू? इसमें भी बता दें.
सर सब्स्टिट्यूशन ट्राई करना.
सब्स्टिट्यूशन ट्राई कर लेते हैं. दिस इज इक्वेशन 1, दिस इज इक्वेशन 2 और यहाँ पे सब्स्टिट्यूशन मेथड करना है तो हम x की वैल्यू लेते हैं और या फिर अगर हम y की भी वैल्यू लें तो भी कोई मसला नहीं है. So let's just say from equation 1, let's just make y the subject of the equation. और ये x को बना लेते. नहीं, अगर हम x को बनाएंगे सब्जेक्ट तो ये इक्वेशन y की टर्म्स में आ जाएगी. y को सब्जेक्ट बनाते हैं. y is equals to 3 minus x. ठीक हो गया? समझ में आया? From equation 1, y is going to be equals to 3 minus x. y को सब्जेक्ट बना दिया मैंने. हेलो.
जी सर.
अच्छा, नेक्स्ट है यहाँ से अब आपके पास जो इक्वेशन 3 आया, यू नीड टू सब्स्टिट्यूट इट इन इक्वेशन 2. तो put equation 3 in equation 2. अच्छा, x squared minus 3 into 3 minus x minus 1 equals to 0, and that is going to leave you with minus 9 plus 3x minus 1 equals to 0. X squared plus 3x minus 10 equals to 0. ये middle term breaking method से हो जाएगा. So you need two numbers. When multiplied, you should get minus 10x squared. The product of the two numbers should give you minus 10x squared, and the difference of the two numbers should give you plus 3x. So 5x and minus 2x. ठीक हो गया?
जी सर.
So that's going to be x squared plus 5x minus 2x minus 10 equals 0. X common आ गया, x plus 5 minus 2 common आ गया, x plus 5. X plus 5 into x minus 2 equals to 0. X equals negative 5 and then x equals positive 2. So these are the two values of x. Now for each value of x, we need to find out the respective value of y. So you can use the equation number 3. Technically, you can use any equation. The reason for using equation 3 is that y is already the subject. So equation 3 is basically equation of y. So I'm going to use equation of y, which is equation 3, because that's what we need to find. Okay, so for x equals minus 5, put x equals minus 5 in equation 3, and that is y minus 3x, 3 minus x, y equals to 3 minus 5, that's going to give you 8. So therefore, the order pair, like the solution set for this one, is going to be x is negative 5 and y is 8. Exactly in the same way, for x equals to 2, put x equals minus 5 in equation number 2. Y, no, sorry, not 5 minus 5. X equals to 2. So y equals 3 minus 2, which is y equals to 1. So our order pair in this case is going to be 2 and 1. ठीक हो गया? समझ में आया?
यस सर.
So
जी.
in short, if you draw the graph of these two equations, these are the 2 points where the intersection is going to take place for both of these. Okay?
Yes, sir.
Acha, it didn't ask for the intersection point, but this is how it is going to be. Acha, in part B is by eliminating y from the equations, show that this is what you get. Okay, now how can you eliminate y from here? Is this suggesting to use elimination method, or is it saying to put y as 2 minus 4x into this? Wait a minute. Let me check if I can actually use elimination method. No, I cannot use elimination method because x is over here as unknown factor of y. So you can't. So all you have to do is put 2 minus 4x in the second equation in y. Upon simplifying, this is what you should get: x squared minus 2x minus 11. Okay?
Yes, sir.
You have to, do you see the question 5?
Yes.
And then it's saying that solve the simultaneous equations and giving your answers in the form of, in the third form. All right, let's just do it. So I'm going to do part A and B together. I actually do it separately. So y equals 2 minus 4x, that's equation 1. And then 3x squared plus xy plus 11 equals 0, that's equation 2. So I'm going to put equation 1 in equation 2. That's going to give us 3x squared plus x into 2 minus 4x plus 11 equals 0. 3x squared plus 2x minus 4x squared plus 11 equals to 0. So 3x squared minus 4x squared is going to be minus x squared plus 2x plus 11 equals to 0. And if I multiply the entire equation with minus 1, I'm going to get x squared minus 2x minus 11 equals to 0. And that's what the examiner asks. And then from here, the part B starts, hence otherwise solve the simultaneous equation. Okay, now from here onwards, I'm going to solve the new quadratic equation which I have obtained in x. And let me see if I can factorize it. Minus 11x squared, and the product of the two should be minus 2. 11 is a prime number. It's got just one pair of factors, 1 and 11. So that's not going to give us negative 2. So the only way out is to solve it by using quadratic formula. So x equals minus b plus minus b squared minus 4ac whole divided by 2a. If you want to make a list to be on the safe side, for the values of a, b, and c, it's always good. B equals to negative 2 and c equals negative 11. All right, now that's going to give us minus and then minus 2 in for the b, so that's going to leave us with positive 2 only. And square of negative 2 is positive 4 minus 4 times a is 1 and c is minus 11 whole divided by 2a. That's going to give us 4 plus, okay, minus times minus is plus. The next term is going to be plus 44 over 2, and then 2 plus minus 48 over 2. Right now, I will have to do the prime factorization of 48. Or what you can do is you can use a calculator to quickly get the prime factors of 48. Or instead, you can put the entire thing in your calculator in one go. So I'm going to press the fraction button first. Now, in the numerator, I'm going to put 2 plus root of 48 over 2. So that's going to, so that's root of, 2 root of 3 plus 1. So the format the examiner has given us, that format looks like this: a plus minus b root of 3. Okay?
Yes.
So we have the constant first. The integer number first. So I'm going to put 1 plus 2 root of 3. So 1 plus 2 root of 3 for the positive sign. I believe you're going to get exactly same thing, except that 2 root of 3 is going to be negative if I change the sign to minus, because that's what the format of the answer shows. Yes. So all I have to do is put a minus sign underneath the plus. Okay?
Yes, sir.
We've got two values of x. All right, now that's for the values of x. The examiner didn't ask you to just solve it for x. This is just examiner is asking you to solve the simultaneous equation. So these are the two values of x. So I'm going to use both of these values in order to find the value of y. So I'm going to equation one is the equation of y. So I'm going to put both of these values of x in equation one. So for x equals 1 plus root of 2 root of 3, put x in, put x equals to 1 plus 2 root of 3 in equation 1. Say y equals to, what was it, 2 minus 4x? Yeah, 2 minus 4x. 2 minus 4, and then 1 plus 2 root of 3. And that will leave you with 2 minus 4 plus 8 root of 3. 2 minus 4 is going to be minus 2. And then next we've got plus 8 root of 3. Okay?
Yes, sir.
All right. And exactly in the same way for the another value of x, for x equals 1 minus 2 root of 3, the answer would be same with the minus sign with the root term, with the term of the root. Okay, so y equals 2 minus 4, 1 minus 2 root of 3. Y equals to 2 minus 4 plus, sorry, I didn't change the sign here. It was supposed to be minus here. All right, so plus 8 root of 3 minus 2 plus 8 root of 3. So x equals, and I'm going to combine the two answers together. X equals 1 plus minus 2 root of 3, and y equals minus 2 plus minus 8 root of 3. Okay?
Yes, sir.
All right, another exam question. Not on 42, 43. Okay, given the simultaneous equations, 2x minus y equals to 1, x squared plus 4ky plus 5k equals to 0, where k is a non-zero constant. Show that x squared plus 8kx plus k equals to 0. All right, all we have to do is, okay, if you look at the equation in part A, you don't have y in it. So all you have to do is, from the equation 1, rewrite the equation 1 as the equation of y, means make y the subject and then put that into this. Okay?
Yes, sir.
That's going to be y equals 2x minus 1. I'm doing it like by skipping the steps. If you don't understand anything, you can let me know, okay? So I've changed the equation 1 to y equals 2x minus 1. Now I'm going to put that in equation 2. So x squared plus 4k, and instead of y, I'm going to put 2x minus 1 plus 5k equals 0. X squared plus 8kx minus 4k plus 5k equals 0. X squared plus 8kx plus k equals to 0. X squared plus 8kx plus k equals 0. Yeah, that's what it asked for. Okay? So
Yes,
find
sir.
the value of k. Now the examiner wants you to find the value of k. All right. Okay, now given that this thing has equal roots. Now, when do we have equal roots? When b squared minus 4ac is exactly equals to 0. If it's greater than 0, if you remember the discriminant part, if it's greater than 0, then we have repeat like sorry, then we have distinct roots. We have two roots, but they are distinct. When the discriminant b squared minus 4ac is exactly equals to 0, then it has two repeated roots. Okay, so that's what is given the answer, that it has equal roots. Now, given that x squared plus 8kx plus k equals to 0 has equal roots, we need to find out the value of k. All right, so in order to do that, I'm going to, as the equation has two equal roots, therefore b squared minus 4ac is going to be exactly equals to 0. So that's going to leave us with 64k squared minus 4k equals to 0. So that's a quadratic with the two terms. All right. Now, I can make this, I can solve this by factorization. So k is common. Oh, no, there was 4k minus 4k. So basically 4k is common, and inside I'm going to left with 16k minus 1 equals 0. And from here, I get two values of k, one as 0 and the other one as 1 by 16. Find the value of k. Okay, so in the beginning, the examiner said that k is a non-zero constant. So I'll have to ignore this one. Therefore, k is 1 by 16. Okay?
Yes, sir.
All right, now in the last part, for this value of k, find the solution of the simultaneous equation. So now we've got the value of k, so I'm going to rewrite this given. Now this, okay, we have technically solved, like started the process of solving a simultaneous equation when we plugged in the value of y into the other equation, and this is what we got. Okay, so we don't have to start from scratch again. So all you have to do is put the value of k into this equation and get the respective values of x then. Okay, so
Yes, sir.
x squared plus 8 over 16, x plus 1 over 16 equals to 0. Now I'm going to multiply the entire equation with the 16. So 16x squared plus 8x plus 1 equals to 0. All right, now I'm going to solve this one by using quadratic formula. Let me just check if I can actually do it with midterm breaking method. So product should be positive 16x squared, and the sum should be 8x. Yeah, 4x and 4x. So 16x squared plus 4x plus 4x plus 1 equals to 0. 4x is common, then I'll be left with 4x plus 1 plus 1 is common, and then 4x plus 1 equals to 0. 4x plus 1, then 4x plus 1 equals to 0. You can see it already coming, that is, it's got two repeated roots. So x equals to negative 1 by 4 from both of them. Okay?
Yes, sir.
So I've got the value of x. So I'm going to put one of these, definitely both the same. So I'm going to put one, x equals minus 1 by 4 in any of the equation given, but I'm going to go for the first one. That's already an equation of y. So 2x minus 1. So I'm going to put x equals minus 1 by 4 in equation 1. So y equals 2x minus 1, and y would be equals to 2, minus 1 by 4, and then minus 1. Y equals to minus 1 by 2 and minus 1. Y equals minus 3 by 2. So the solution set for this one is going to be x is minus 1 by 4 and y is negative 3 by 2. Now this shows the intersection of the two equations is just at one point. Okay?
Yes. So can we take this as like the turning point because it's like one is still a quadratic equation and one is a linear. So if they're only intersecting at one point, then would that make it the turning point of it?
Now, okay, now look, there is a possibility, but that's not the rule. Because, for example, I have an equation like this. It's crossing the line at just one point, like this.
Okay.
All right, let me just
Yes.
try drawing the line for it. Okay, one of the equation was 2x minus 1 equals, sorry, 2x minus y equals to 1. All right, so 2x minus y equals 1. All right, now the other equation was, okay, that's a bit complex. X squared plus 4. K was 1 by 4, isn't it? No, 1 by 16. So 4 over 16 is going to be 1 by 4y. So x squared plus 1 by 4y, x squared plus 1 by 4y, or y over 4 plus 1 over 4. And no, not 1. It's 5k, so that's going to be 5 over 4. That's equals to 0. No, doesn't show the intersection at all. X squared plus 4ky. 2x minus y equals to 1, that's done. X squared plus 4k. K was 1 by, was it minus 1 by 4 or just 1 by? It was, sorry, it was 1 by 16. Alright, fine. So that's going to be, actually, wait. I'm going to put everything as it is. So 4, and then y over 16. And then plus 5k is going to be 5 over 16. It's tangent to 1 point. Oh, it's going to be tangent. It's not going to be cutting the cutting the graph. Sorry.
Okay, sir.
It would be tangent because discriminant was equals to 0. Wait a minute, where did it say? There. When the discriminant is 0, exactly equals to 0, then it just touches the graph at 1 point. It's not necessary that it always touches the turning point. It can be tangent at any point. Okay.
Got it, sir. Yes.
All right. Now the next thing is exam question.
They're on page 49, sir.
Page 49. Okay.
Yes.
Yeah. Okay. Question 6. Find the set of values of x for which x squared minus 5x minus 14 is greater than 0. Okay. So we need to solve, basically, we need to solve this quadratic inequality. So let's just see if we can actually factorize it. So I need the two numbers when multiplied. You should get minus 14x squared. And the difference of the two numbers should be negative 5x. 7 and 2. So 2x times minus 7x. Okay?
Yes.
All right, so x squared plus 2x minus 7x minus 14 is greater than 0. All right, the first thing was to check if the coefficient of x squared is 1, which is already 1, so we don't have to worry about it. And it should be positive, which is again positive. Okay, so x is common. And x plus 2 minus 7 is common, and then x plus 2, and then that is greater than 0. X plus 2 is common, and then I'm left with x minus 7 is greater than 0. Now, when it's the case of greater than 0, then the solution is, okay, now from here, wait a minute. Okay, this is how you're going to do an exam. Let x plus 2 times x minus 7 equals to 0. Then you need to put here let, so that examiner knows that you're writing down its associated equation. Then x would be equals to negative 2, and x would be equals to positive 7. Therefore, x is less than negative 2, and x is greater than positive 7. It's the solution, if you remember, when it's a greater than sign, then the solution is greater than the larger number, and the solution is smaller than a smaller number. Okay?
Got it, sir. Yes.
All right. Next is just a quick demonstration of this concept, a quick recap kind of thing. This is how the graph of this quadratic looks like. So minus 2 is going to be over here, and positive 7 is going to be here. So y is greater than 0 in this case over here. So whatever the solution is, it is less than negative 2 and greater than positive 7. Okay? Just in case if you forget what was when it was a greater than sign, then what was the rule, you can quickly draw a graph and check. All right, so the next part, that's okay, now question number 7. Find the set of the values of x for which this is less than this. All right, this is a linear inequality. All right, so I'm going to expand it. So that's going to leave us with 6x minus 2 less than 4 minus 3x. So I'm going to collect the like terms together. 3x, oh, sorry, 9x. 9x less than 6, and x is less than 6 over 9, which will leave you with
2 over 3.
so x is less than 2 over 3. So that's the solution for the first part. Part B says that we need to solve it for 2x squared minus 5x minus 3 is less than 0. All right, now we need to make the coefficients of x squared as positive. That's already positive. Okay? All right, so we don't have to worry about anything. So if I try solving it with the factorization method, that's I need two numbers, one multiply, you should get minus 6x squared, and the difference of the two numbers should give you negative 5x. 1x and
6.
1x minus 6x, isn't it?
Yes.
All right, so 2x squared plus x minus 6x minus 3 less than 0, and then x is common. 2x plus 1 minus 3 is common. 2x plus 1 less than 0. 2x plus 1, x minus 3 less than 0. Now from here, we're going to say let 2x plus 1 times x minus 3 equals to 0. And then from here, you can say x equals negative 1 by 2 and x equals positive 3. Now, when this was the case, then the solution where in the case of less than, the solution was between the two roots. And this is how you're going to write them down. So x less than sign on both sides, and negative 1 by 2 comes here, positive 3 comes here. Now, if I, just in case, for example, if I'm sitting in an exam and I completely forgot that what was the situation whenever it was a less than thing. So this is negative 1 by 2, this is positive 3, and the solution is less than 0 means the solution is going to be below the x-axis, and below the x-axis I can see the solution is between the two roots. Okay?
Yes, sir.
Alright, so you can always check in your rough work. Alright, so that's the solution of part B. In part C, both, okay, now we need to solve them together. I know how to solve them together. We will be drawing this information on a number line. In part A, what did we get? Is less than 2 by 3, so 0 point something. And in part B, it says, okay, 0, 1, 2, 3, negative 1, negative 2, and that's it. Now, according to the solution to the part A, x is less than positive 0 0.6, I guess. 2 by 3 is, yeah, 0 0.6. So, for example, that's there. Wait a minute, I'm going to do it with the orange for the first part. So let's just say 0 0.6 is here. So the solution for that one is going to be like this. Okay.
Yes.
All right. Now the solution for the second one is that x is greater than. Wait a minute. Let me just draw this clearly. That x is greater than negative 1 by 2, which is negative 0 0.5. So let's just say over here, x is greater than this and less than 3. So that's the solution. Now, the common region of both of them is this one. Okay, so the solution
Yes, sir.
is combined solution for both of them is going to be that x is greater than negative 1 by 2 and is less than 2 by 3.
Got it, sir.
Got it?
Yes.
Okay, what next? Given that x is not equal to 3, find the set of the values for which 5 over x minus 3 is less than 2. Okay, so 5 over x minus 3 is less than 2. The important point which is mentioned in the beginning of the question is that x is not equals to 3. Why? Because if you put x as 3, then we have 0 in the denominator, which is not very nice. Having denominator in the 0 is like undefined. Okay?
Yes, sir.
Okay. Now we need to solve this. We're going to take that on the other side first. X minus 3 times 2. So 5 is less than 2x minus 6. 5 plus 6 is less than 2x. That is 11 is less than 2x. 11 over 2 is less than x. So that leaves us with x is greater than 5.5. Why having 6 marks for this? Now there's something I'm missing. Find the set of values for which 5 over x minus 3 is less than 2. Wait a minute, I'm going to apply another technique here. So if I flip the fraction, let me see what happens to the x
Sir, the
over 5 greater than 1 over 2.
The answer in the back is the same, so you did do it correctly. I don't think there's more to it.
Uh-huh.
Yes, but I think we need to find a set of values, and that's just x is greater than 5.5.
Huh. Okay. Maybe examiner is being generous over here by giving 6 marks for this piece of cake. Or maybe it's a typing error. Okay, the equation this where k is a constant has no real roots. Prove that k satisfies the inequality. Alright, so it has no real roots. So basically, the discriminant of the equation is less than 0. Okay?
Yes.
So b squared means 2k and then the whole squared minus 4a and then c, that should be less than 0. That's going to leave us with 4k squared minus 12k and less than 0. If I'm going to take 4k as common. This is a quadratic, but I don't have, I can factorize it by just simply taking common. So 4k is common, so k minus 3 is less than 0. All right, now in this case, again, I've got, so let 4k times k minus 3 equals to 0. So that is going to leave us with k equals 0 and k equals 3. Therefore, the solution, okay, it was less than 0, which means the solution is going to be between the two roots. So therefore, k is from 0 to 3. Got it?
Yes, sir.
All right. So prove that k satisfies the inequality. But wait a minute. Why does it say k is less than or equals to 0? If I put k as equals to 0, that's not quadratic anymore. That leaves us with 3 equals to 0. Yeah, that is not possible again. That that makes sense then why they're saying this equals, but with the help of a procedure, how am I going to get equal here? So I'll look into this and I'll tell you in the next class, okay?
Okay, sir.
Acha. Inequalities on graphs. Exam question. Oh,
The next exam questions are in the chapter review on page 54
page
and
54.
55. Yes.
Okay, so one we've done these, isn't it? No, they're different. Okay. Question 1, I think you should be able to do it. It's exactly same as the one we've already done. Question 2, again, same. 3, given the simultaneous equation, this will show that this is how it is reduced. Okay, we've done the question of the same sort, but in that we were supposed to reduce it into the equation of x. It was a quadratic equation with x in it. Over here, it's a quadratic equation in y. So in order to get a quadratic equation in y, you need to change the equation 1 to equation of x. You means you need to make x the subject. Okay, so that's going to be x equals 1
Yes.
plus 2y, and then you put that into equation 2, and then after simplifying it, you should be able to get 5y squared plus 3y minus 8. Okay, next is by eliminating y from, okay, hence find x and y. Okay, by the next is basically solution of the simultaneous equation. By eliminating y from the equation, show that this, hence or otherwise, we've done this type of question as well. 5, given that this, show that this all the simultaneous equation.
So can you read
Okay,
this
part
one, question 5?
A is different. Yeah, part A is slightly different, but it's easy, don't worry. It's about using the rules of indices. So 3 to the power x equals 9 to the power y minus 1. Now the examiner is asking you to show that x equals 2y minus 2. All you have to do is apply the rules of indices. How are you going to do that? You need to change this base. But in short, you need to make them same. You can't change 3 to 9, but you can change 9 to 3. So 9 can be written as 3 squared, isn't it? So 3 to the power x
Yes.
stays as it is. So this side, I'm going to write down 3 squared, and then y minus 1 will be multiplied with a new power. So 3x equals 3 to the power 2y minus 2. Now, once the bases are same and it says it's equal, it means the powers are same as well. So that leaves us with x equals 2y minus 2. Yeah, that's what you were supposed to show. Okay?
Yes, sir.
All right. 6. Part B is easy. Question 6 is easy as well. The curve and the line given by the equation this, where k is a non-zero constant, intersect at a single point. Again, it's tangent, okay?
Yeah.
So basically, what are you going to do here over here is you are going to put equation 2 in equation 1 after making it, like, first of all, you need to change equation 2 to equation of y. By making y the subject of the equation, put that in equation 1. You will have a new equation. For that, you need to check the discriminant. Once you're checking the discriminant, from there, you will be able to get the value of k. Should we do it?
Yes.
All right, so the first equation is kx squared minus xy plus k plus 1 times x, and that is equals to 1. And the second equation is minus k over 2x plus y equals to 1. All right, now here examiner is saying to, the first part is to find the value of k, and it's a non-zero. All right, so what I'm going to do is I'm going to rewrite equation 2 and make y the subject. So from equation 2, I will have y equals 1 plus k over 2x. Now I'm going to put equation 3 in 1. And that will leave us with kx squared minus x. And then for y, I'm going to put 1 plus k over 2x plus k plus 1 into x equals 1. All right, that doesn't look in shape, so I'll be expanding it. So kx squared minus x minus k over 2x squared plus kx plus x equals 1. All right, now I'm going to put these two together. Kx squared minus k over 2x squared, and then minus x plus kx plus x, and then minus 1 equals to 0. I've brought this one on the left as well over here. Okay.
Yes, sir.
Now, if I take x squared as common and k as just x squared, so that I can split the constants or the coefficients. So k minus k over 2, and then x squared. And then from the next part, if I take minus x as common, then inside I'll be left with 1 minus k minus, oh, that's easy. Wait a minute, I didn't see that. Minus x and plus x, that will be cancelled out. I'm only left with just kx. Okay?
Yes, sir.
And then minus 1 equals 0. Now that's a proper shape now. Now b squared minus 4ac should be exactly equals to 0, as it, but why the examiner is using the term intersect? Should have said tangent. Anyway, at it intersect at a single point. So k, sorry, b squared minus 4ac should be exactly equals to 0. I'm doubtful about this one. Okay, so b squared, b is k, so k squared minus 4a. A is, okay, now I didn't simplify this. K minus k by 2 is going to give you just k by 2, isn't it?
Yes, sir.
So for a is just k by 2, and c is negative 1. And this is going to give us k squared minus, not minus, plus, because this is negative as well. And then k squared plus 2k equals to 0. K is common, so k plus 2 equals to 0. K equals to 0, and k equals negative 2. So it's, as the examiner said, that k is a non-zero constant, but I have to ignore the value of this one. So I'll just stick to the non-zero value of k, which is k equals negative 2. So that's the value of k. That's the first part. Can you check the answer for this one if it's given?
In the back of the book.
Yeah.
Oh,
Is it negative 2?
1 second.
I think this is it. It's negative 2.
Yes, sir. It's negative 2.
All right, great. Now, in the next part, give the coordinates of the points of intersection of the line and the curve. In short, he's asking you to solve the simultaneous equations, okay? Okay, now
Yes.
again, we actually started the process of solving over here when we substituted that. And this is where we ended up with. So all I have to do is plug in the value of k into this and have the equation. So I'm going to put value of k in there. So minus 2 over 2x squared plus minus 2x minus 1 equals to 0. You can even name this equation so that you can tell the examiner where you're plugging it into. You can put here that put k equals minus 2 in equation 4. All right, so negative x squared, negative 2x, negative 1 equals 0, which is x squared plus 2x plus 1 equals to 0. All right. I don't think so. This is correct. Wait a minute. Let me just check again. K equals minus 2. Minus 2 over 2 is minus 1. K is and so minus 2 over 2 is minus 1. Minus x squared. Minus 2x. And minus 1. So minus x squared minus 2x minus 1 equals to 0. X squared plus 2x plus 1 equals to 0. Oh yeah, we can actually solve it. Sorry. So that's going to give us x squared plus x plus 1 equals to 0. The product of the two should give you just plus x squared, and the sum should give you 2x. So that's 1x and x. Okay? X is
Yes, sir.
common, x plus 1 is common, and then x plus 1, x plus 1. That's a repeated roots, yes, because definitely it's touching at 1 point. So x equals minus 1. So that's the value of x. We need to find out the value of y. For that, we can refer back to equation 3. So y equals 1 plus k over 2x. So I'm going to put x equals minus 1 in equation 3. Y equals 1 plus k over
K over
2.
2.
Yeah, k over 2x. So y equals 1 plus minus 2 over 2, and then x is minus 1. So y equals 1 plus 1, and y
2.
equals 2. So the intersection point is x equals minus 1 and y equals 2. Got it?
Got it, sir. Yes.
All right, question number 8. Give your answer in the set notation. Question 8. Where it's a linear inequality and then a quadratic inequality, you need to solve them together. Okay?
Yes.
Okay, use algebra to solve it. Okay. Okay, no. Find a set of solutions for x. Okay, now it looks difficult, but it's not. It's x. I'm talking about question 9. X minus 1 times x minus 4, and that's less than 2 times x minus 4. Do the expansion and you will see the equation coming into shape, and that's going to be a quadratic inequality. Okay, that's going to leave us with x squared. I'm doing it directly, okay, minus 5x plus 4 on the left hand side. On the right hand side, I'll be left with 2x and minus 8. The x squared minus 7x plus 12 is less than 0. Okay,
Yes.
but can you solve it by factorization? Yeah, 4 times 3. So you'll be splitting it as minus 4x minus 3x. And then you can solve it from there. Okay?
Yes, sir.
All right, question 10. Use algebra to solve x minus 1 times x plus 2. And that is equals to 18. Just give me a minute, please.
Oh, yes.
Assalamu alaikum. ठीक ठाक जी, आप सुनाएं. हाँ हाँ, वो मेरे वाले में नहीं था, मेरा ख्याल है अब्दुल्ला वाले में था, क्योंकि मैंने अपना पहना था उसमें क्लियर था. हाँ जी, मैंने कहा वो जो मेरा वाला था ना, मैंने पहना था उसमें कोई नहीं आया था, वो मुझे याद आया था, फिर अब्दुल्ला वाले में होगा शायद. हाँ जी वो ठीक. नहीं, वो साइज तो देना ही था ना. ठीक है. अच्छा, उसको बोलना है कॉलर पे नहीं करे वो कढ़ाई. हेलो हेलो.
Sir, are you calling me?
No.
Oh.
जी नहीं साइज पे तो देना ही था ना। हाँ ठीक है, हाँ उसके पास ही पड़ा रहे, और दूसरा उसको क्या है वो कॉलर पे ना करे उसके। शायद लगाऊं, देखो मैं उसको पता नहीं। ना ना मेरे दे दे, मेरा क्लियर है, मैंने पहना था ना। ना ना उसके पास नाप वो देख लें, अगर उसको उसको कहता है कि ठीक है, अगर जो उसके पास नाप लिखा हुआ है और तो ठीक है, नहीं तो अगर वापस देना है उसने दे वापस देना। चले ठीक होगा। Okay, so now this one from the left hand side, if you look at the fact, hello, you there?
Yes, sir.
Okay, now if you look at the left hand side, by looking at the factors, you can clearly see that upon multiplying this, you're going to get a quadratic. But we don't have 0 on the right hand side. So I'll have to expand the left hand side first. So that's going to give us x squared plus x minus 2 equals to 18. I've expanded it directly, okay? And then in the next
Yes, sir.
step, I'll bring the constant 18 on the left, and that's going to give us minus 18, and minus 18 and minus 2 is going to be minus 20 equals to 0. Now that's the proper format. Now I'm going to factorize it again, and this is going to give us x squared plus 5x minus 4x, and then minus 20 equals to 0. X common x plus 5 minus 4 common x plus 5, and x plus 5 x minus 4, and then x equals negative 5, and then x equals 4. So we've solved it. Okay. Hence or
Yes, sir.
otherwise find the values of this, like it's greater than 18. Okay, the same thing. So instead of that, we are going to have like it's greater than that. So if it's greater than 18, so everything is going to come down as it is up till here. Okay. Now going from there is the greater than sign, so it's just going to be greater than the larger number. So x is basically less than minus 5 and x is more than 4. Okay,
Yes, sir.
can you check the answer for this one? I actually just want to confirm that why is it saying give your answer in set notation? I think this is the answer in set notation. Or you can write it down as no,
Yes,
this is
sir.
it.
This is. But in the back, yeah, it's given in set notation. It's like bracket x equals to x
How?
is like smaller than -5, and then bracket, and then it's union x
Okay, yeah. Fine,
equals,
got it.
yeah.
So basically, x is less than 5 for and they have used the term union for like the all values of these, combine them together with x more than 5. Like this?
And no, they're in different brackets though. But yeah,
Like
for
both
the
of these?
most part, it's like that. Yeah.
Okay. Now find the set of values for which this, okay, now part A is linear, part B is quadratic, part C is linear. Okay, I did something in the previous question which I forgot to tell you. No, not the previous question. Do you remember the question for which I was saying why 6 marks for it? I was checking something on the right
Yes.
hand side. Do you remember that if you multiply or divide an inequality with a minus sign, then the inequality changes? Okay. Do you remember that rule? Okay. Now
Yes.
inequality also changes if you, for example, if you have single terms on both sides, you can clearly see that you have one term on the left hand side and you have one term on the right hand side. So talking about equation, So whenever you have this situation that you have a single term on both sides, you can easily flip the entire equation like this without worrying. But if there is another term with it, like for example plus 4, then you can't do this. It has to be single term on both sides. Okay, now if I'm doing the same for the inequality, I can flip it, but it's going to change the inequality. Okay,
Yes, sir.
and you can solve it from here. 20 over 5 is greater than x, so 4 is greater than x, or x is less than 4. And then the examiner asks you to solve one linear and one quadratic together. That the first linear is part A and the quadratic is part B, so you need to combine the solutions of both. All right, look at question number 12. So 8 over x squared plus 1 is less than 9 over x. So x squared will be the LCM here, so 8 plus x squared less than 9 over x. So I have actually converted this into single fraction, but there is no point of flipping, because if I flip it again, I will have this variable in the denominator. So I'm going to do the cross multiplication here. So 8x plus x cubed, okay, less than 9x squared. So x cubed less than, sorry, x cubed minus 9x squared plus 8x is less than 0. All right, now from here, don't get worried that this is a cubic inequality. You're going to deal it exactly the same way that we've been dealing with the inequalities and equations earlier. If you look carefully, you can take x as common from the entire thing, isn't it?
Yes.
So x I've taken as common, and I have x squared minus 9x plus 8, and that is less than 0. Now from here, I'm going to solve, like factorize this one further. So that's going to leave us with product should be 8x squared, and the sum should be minus 9x. So x squared minus 8x minus x plus 8, x common, and then x minus 8, minus 1 common, and then x minus 8. Okay, x minus 8, x minus 1 is less than 0. Right, now I have 3 factors now. Now let x into x minus 8, x minus 1 equals to 0. From here, I have x equals to 0, x equals to 8, x equals to 1. What's the smallest one here?
0,
What's the largest one?
8.
8. So the solution is going to be between 0 and 8. Check the answer.
Okay.
Oh, wait. X is not equals to 0. Actually, okay, check your answer first. If it's not equals to 0, then
It is 1 is greater than and equal to x. No, I mean x is greater than and equal to 1, and then 8 is greater than and equal to x. There's
wait
a
a minute.
line under there.
X is greater than equals to 1. Is that what you said?
Yes. And then
And
8 is greater than and equal to 1. But it's all in one line,
Can you send me the
like the one
picture?
you wrote. Sir, can you repeat what you said?
Send me the picture of the solution.
Okay, one second.
Okay, so it's this one, right?
Yes, sir.
Okay, and equal to sign, because I didn't write the question properly. There was equal to sign as well in the question. Oh, I wrote the question properly, but I forgot to carry forward the equal to sign. Okay, so in the answer, you're going to have this one. Okay, now why this solution instead of this one? We have to ignore zero, because in the question, if you read at the end that x is not equals to zero, so you have to ignore this part.
Okay, sir.
Okay.
Yes.
All right. Question 14. The equation this where k is a constant has no real roots. Okay, discriminant should be less than 0. And then from there, you should be able to get this value of k. Okay?
Yes, sir.
Minus 5 by 2. Okay, k is greater than minus 5 by 2 and less than 0. You should be able to get that. 15. Sketch the graph of this and this on the same axis. Find the coordinates of... Okay, now this is important. Okay, now I'm going to use the software to sketch the graph for both of these. All right, so x squared plus 2x minus 15, y equals x squared plus 2x and then minus 15. Okay, and then y equals 6 minus 2x, isn't it? Wait, x squared plus 2x minus 15. What question we are doing? 15, right? Question 15,
Yes,
x
15.
squared plus 2x minus 15, and the other equation is y equals 6 minus 2x. Y equals 6 minus 2x. Okay, now as you can clearly see that the intersection points are these two. This is how you'll be drawing the graph. It's not necessary, whatever graphing grid, like whatever the scale of the grid you're using, it's not necessary to have both the intersections clear on your graph. Find the coordinates of any points of intersection. That is why the examiner is saying for any points of intersection, because you won't, maybe there are chances that you won't be able to see this one because it's too high up on the y-axis. Okay, but you
Yes,
should
sir.
be able to see this one over here because that's in the range of normal scale. That's 3 and 0. Okay, this is what we need to tell about that. Okay, the next is write down the set of the values of x for which f of x is greater than the g of x. Okay, now that's important. Like this. Okay, now I'm going to import the picture here. Okay, now this orange graph is basically, oh, the turning point is gone. Sorry, I'll have to do it again. All right, now the examiner is asking you to write down the set of values of x for which the function of x is greater than the function of g. Now, function of x is the orange line over here, the orange curve, the quadratic curve. This is the function of x. So let me just tag it as f of x. And this blue straight line, that's g of x, isn't it? If you look at the question, the g of x is a linear function, the f of x is the quadratic function. Now he's asking you the values for which it is greater than that. So we need to look for the orange line, which is above the blue line here. So it is above over here, isn't it?
Yes, sir.
Like this part, it's above the blue line, and it's above the blue line over here as well, isn't it?
Yes, sir.
Okay, now the moment I come here, okay, let me explain it to you this way. From whatever value of x is over here, the moment I move further, the orange line goes beneath the blue line. See? The more you go ahead of it, the orange line goes underneath that blue line. So I need to tell the values where orange line stays above that. So for all the values of x less than this intersection point, less than this intersection point, the orange line stays above the blue line. And on the other hand side, over here, if you go behind this point, the blue line is above the orange line. I need to look for the values where the orange line is above the blue line. So the points after that. So if you look carefully, whatever this point of intersection is, I guess it's -7. It is -7. Yeah. So x should be less than -7 and x should be greater than 3. Huh. Check the answer. It asks for the values of x, so that is why I check the values of x. So for all the values of x greater than 3, the
Yes, sir.
orange line is above the blue line. Okay? For all the
Yes, it's the
values
same answer.
less, okay, for all the values less than -7, the orange line is above the blue line. Got it?
Yes, sir.
Okay, find the set of the values of x. Okay, for example, if the examiner would have said that f of x is less than g of x, so we would have been looking for the values of x for which the orange curve is below the blue line. So the points after this, so it would have been x is more than -7 up till here. This is the region where the orange line stays below the blue line. See? That's the blue line, and the orange line is underneath it. So from here, no, not from there. From here till here, the orange line stays below that. So less than these and more than this, the orange line goes above the blue line.
Got it, sir.
Okay, find the set of the question 16. Find the set of the values of x for which the curve with equation. This is below it's exactly the same question. Okay, but instead of giving it a notation of the function, he's saying the curve should be below the linear line. Okay, you need to tell
Okay,
all the
sir.
values of x. On the coordinate, shade the region that satisfies the inequality. Okay, now that's important again. That's a different sort of a question. So one of the equation is x. So I'm just drawing the curve because this is how you're going to do in exam. I'm not going to write down the inequality, okay? So I'm going to write down its associated equation. So y equals to x squared plus 4x minus 12. So that's the curve for the first part of the first equation. And the second equation is going to be y equals 4 minus x squared. There you go. जी जी हाँ हाँ खैर खैर कोई मसला नहीं ठीक है ठीक है all right so there you go you have these two curves okay now let's just import that here okay now the green one is the second one the gray one is the first one and the examiner wants you to find out like you need to shade the region where y is okay now for just focus on the gray function first okay once you have the graph there once you have the gray function says that y is greater than this function y is greater than this function you need to and for the second part it says y is less than this function so which part should be shaded
The one that is like below the green line and above the green line.
all right so let's just change these two inequalities over here I'm going to do greater than and in this one I'm going to do less than perfect okay so the common
Yes, sir.
region is so this is what you're going to say
So we would take like x is minus 4 as the lowest point, and then x is like the 2.
sorry I didn't get your question
So for if we are, they only ask us to shade the region, but if we were to like write it down for like the
the,
values of x, we'll take
the
it like
extreme left
x.
point
Yeah.
this one till this one minus 4
Oh,
to 2 yeah
okay, sir.
okay on a coordinate grid shade the region that satisfies the inequality all right now that's basically all three are linear inequality this time okay
Yes, sir.
all right I'm going to quickly draw the graph for all of these y-axis that's x-axis now the first equation is y is less than minus x plus 6 okay so y-intercept
Yes.
is 6 1 2 3 4 5 6 and the gradient is minus 1 so whenever you have a gradient of minus 1 whatever the y-intercept is x-intercept is going to be same as well that's plus 6 okay
Yes, sir.
so 3 4 5 6 so this is how the line is going to be okay next is y is 2x plus 9 okay that is going further up okay that was 6 1 2 3 4 5 6 7 8 9 that's the y-intercept and the gradient is 2 so it's going to be 2 over 1 That's the y-intercept. 2 units rise from here, and 1 unit run. This is how the line is going to be. Like this, okay?
Yes, sir.
Okay, the next is y equals to 3. So that's going to be a horizontal line at crossing the y-axis at 3. And the last one is x equals to 0. That is the y-axis itself. Let's see if I can change the colors. Style yellow. Yeah. And the last line is the x-axis, y-axis itself. I'll change that to yellow as well. Okay, now moving on to the shading part. So the first one, it was less than this line. So whatever the area is, it is going to be underneath this line. Okay?
Yes, sir.
Next is y is less than 2x plus 9. So for the second one, it is also underneath this line. Y is greater than 3, so it's going to be above this line. X is greater than 0, it's going to be on the right-hand side of this line. So the common region for all of these is this one, this triangle you see here,
Yes, sir.
because this region is underneath this, above this, on the right-hand side of this, and it's also underneath this one. So that's the region the examiner asked for, and the next part is asking you to find out the area. It's a right angle triangle. So 3 units is its base, and perpendicular height is also 3 units. So 1 by 2 times 3 times 3, so 9 over 2 is 4.5 squared units. This the unit was not given if it's centimeter or what, so I've written it simply square units. Whatever the units are, the square of it. Okay,
Yes, sir.
that's it. All of them. Okay.
Yes, sir.
Chalo, any questions?
No, sir. No questions.
Chalo. In the next class, inshallah, we shall be starting off with the transformation of the graphs.
Okay, sir.
Okay.
Yes, sir.
Chalo. All right, dear. Take good care of yourself. Inshallah. See you in the